Hello, welcome back for the extra little question example from chapter 7 that somehow did not get put on the previous video. So this is example 16. What's important is the content. It says, according to a 2018 Vox poll, 45% of Americans report watching the Super Bowl yearly. Suppose a sample of 100 Americans is randomly selected. They would like us to verify that the conditions of the central limit theorem for proportions are met. Then we're going to describe the sampling distribution using correct symbols. And then we're going to find the probability. There's a few probabilities that we're going to find. So let's look at parts A and B. If we go up here, these are our three conditions for proportions. Condition 1 is the same as it was for the means. Each observation is randomly selected from the population. Condition 2 is also about independence, whereas we need to prove that our sample is 20 times our sample size is less than or equal to the population size. And then the condition 3 for normality is a little bit different. We have to show that n times p times 1 minus p is greater than or equal to 10. And we are going to go ahead and do that. I'm going to show you my page here. So they told us that they took a random sample, so we're going to say that one is the net. You at least have to acknowledge it. And then if I take 20 times my sample size, which would be 20 times 120, gives me 2,400. And yes, I believe that there's at least 2,400 people in the population, because our population would be the US, adults in the US watching TV, I guess. And then to show normality, so this is for the independence. And then this is to show that it's normal for the distribution. N times P times Q is greater than or equal to 10. So N is 120. P is 0.45. And Q is 1 minus P, so that would be 0.55. So we need to show that that is greater than or equal to, I'm going to go here to Desmos and type 120 times 0.45 times 0.55. And that comes out to be 29.7. And that is equal to 29.7, which is greater than or equal to 10. So we definitely have met all three of our requirements. There. So there's our third requirement, normality. Then to describe our distribution, we're going to say the mean of the proportions is going to be our sample proportion, or what they think is true from the population P, which is 0.45. And then our standard error, which is the standard deviation of the proportions, is taken by the square root of P hat times 1 minus P hat over N. We were given what they think is true about the population, so that would just be P times 1 minus P over N. So in our case, that would be the square hat of 0.45 times 0.55 over 120. And I'll show you what that is in Desmos. And we're going to use these as our basis for all of our calculations. And so our standard error is 0.0454. And we can just use the raw calculation in normal distribution. So the question that they're asking here is, find the probability that the true proportion or the sample proportion of people that watch the Super Bowl is between 41% and 46%. So I'm going to show you these in Desmos. So in Desmos, we're looking between 0.41 and 0.46. So my min is going to be 0.41. My max is going to be 0.46. And I've already put in the center of our proportion, which is 0.45. And then our standard error calculation is right here. So that likelihood is 0.3979. Okay. Then part D says there is a 10% chance that the sample proportion of Americans who watch the Super Bowl yearly in a sample of size 120 will be at or below. So in this case, we're going to use the inverse CDF because we know the area is 0.10 and it's 0.10 is at or below. So it's going to be a less than where the p hat is less than something. So let me show you what that would look like shaded on my paper. This is what we're looking at. And our curve would be something like this. And we're looking at 10% of the p hats would be here at this p hat value. So we're going to use an inverse CDF. And Desmos. And similar to what we've done in other problems up here. I'm just going to copy that and paste it. But really, I'm going to paste this inside here. And we want this to be 10. And that's 10 to the left. Oh, no. Okay. So it looks like that p hat would be about 0.3918. Then the next question says, so you conduct a poll of 120 Americans and find that fewer than X equal to 32 of them watch the Super Bowl yearly. Is this unusual? So the first thing we have to recognize is that they didn't give us a proportion. They just said less than 32 of them. So we need to find out what that p hat is, and we needed to decide if that p hat is unusual or not. So X equal to 32 gives us a p hat of 32 out of the 120. And we want to know if the probability of that p hat being less than this proportion. So 32 out of 120. .2666. Okay. So what we can do is we can, this is going to be a normal distribution because we're looking for a probability. And it is going to be cumulative, and we're saying less than this. So right here in the max, because it's a less than, we can just put 32 divided by 120. So it gives the exact calculation. And I'm going to click on my magnifying glass just so you can see what's being shaded here. We're going to take that one away. So, and it's so small, we can't even see it over here. So small, very unlikely. So the probability of it being less than 32 out of 120. So less than 32 of the people sampled out of 120 that says they're going to watch the Super Bowl yearly is 0.000271. So very unusual because it's less than 5% or less than 0.05. Show you my paper here. So it's very unusual because this is the probability and it's less than 0.05, which is 5%. And let's look at the last question. So the last question says, suppose the scenario above in part E actually happens where less than 32 people out of the 120 Americans watch the Super Bowl annually. List the 3 conclusions you might draw with explanations. So here, the first one would be is maybe we did not get a good random sample. It could be just a fluke is one of the possibilities. Or maybe the true proportion who usually watch the Super Bowl, not actually 45%. Like they said here. Maybe that's really not true from the poll that they took is not a good number to use. So those are our 3 possibilities. Hopefully this extra example helped you gain some understanding for chapter 7. Catch me back.